Hey everybody, BigStew here, and today's video is a shout out to the seniors who are graduating. I know that things aren't quite the way you had planned, but I have a specific shout out tonight, and that is to the seniors of Meridian High School, class of 2020. Congratulations, I am so proud of you. Way to go, Wildcats for life. All right, now, speaking of Wildcats, one of my classmates, Ollie Perry, is probably the one person on this earth who loves bacon more than I do. And I got to thinking, well, how can I incorporate bacon into a video about Newton's laws of motion? Let me explain. Keep in mind, to do Newton's law, remember you have to multiply mass times acceleration, and that tells you how much force you need to use. Now, force is measured in newtons. Sound like a familiar unit? There's a reason. In science, when you do something cool, when you die, there's a key point right there. When you die, they name it after you. So they named the unit of force after the guy who came up with the laws of motion. So newtons are named after him. Now, we're going to do a math problem, and I realize that for some of you, you think math and you, woo, yay, numbers, yay. And then some of you, the idea of math just makes your butt cheeks clench. I get that. I want to try and make it as easy as possible for you to work with. And I understand because math was not always my friend in school. All right. We're going to measure mass, the M in the formula. We're going to use kilograms, kg. And in this instance, we're going to use the acceleration, the A, as meters per second squared. Now, when you put all that together, you have kilograms per meters per second squared. That's a lot to have to say. So we're just going to call the units for force N for newtons. All right. Let me give you an example. Let's say that my buddy Ollie goes to the grocery store and he's out of bacon and he needs more bacon. So he picks up a package of bacon, and let's say that that package of bacon has a mass of 1 kilogram. That's a reasonable sized package of bacon. And the acceleration that Ollie has to use to put that bacon in his grocery buggy, let's say is 0.5 meters per second squared. All right, well, if we use force equals mass times acceleration, we have 1 times 0.5, which gives you 0.5 newtons. So my friend Ollie had to use half of a newton of force to lift a 1 kilogram package of bacon off the shelf and put it into his grocery buggy. Well, that's all fine and good, and that's not a lot of force. Let's say one package of bacon just wasn't enough, because you know what goes good with bacon? More bacon. All right, so let's say that instead of one package of bacon, Ollie decides that he's going to buy the whole hog. All right, that's not an uncommon thing. Lots of people buy a whole side of beef. If you go hunting and you shoot a deer, you process the whole deer. You've got lots and lots of meat. Well, Ollie, Mr. Bacon Man, wants that hog. So he's going to buy a hog that has a mass of 100 kilograms instead of just 1 kilogram. All right. In this case, the acceleration to be able to get that into the buggy is still 0.5 meters per second squared. It's still multiplication. You're still multiplying the math times the acceleration. So 100 times 0.5. And an easy way to do this, take a look at this. If we were to put an imaginary decimal right there behind the 1, notice we have 2 zeros here. We're going to take this decimal right here and we are going to move it over 2 spots. And so we need to add a 0 here to give us a total of 50 newtons. So a lot more force to pick up that whole piggy and throw it in the buggy compared to one package of bacon. So, Ollie, thanks for being part of my video today, man. Miss you bunches. Can't wait till the next reunion to see you and all the other Meridian High Wildcats. Class of '89, Wildcats for life. Y'all take care.